Hooke's law was discovered by physicist Robert Hooke during the 17th century when studying springs and elasticity. He found that compressing or stretching a spring moves it away from equilibrium and requires a force to be applied.
The force exerted by the spring is always opposite of the motion. When the spring stretches, the force will pull in. When the spring compresses, the force will push out.
The equation for Hooke's law is F equals negative K times X. F is the restoring force of a spring and is measured in newtons. K is spring constant and is measured in newtons over meters. X is the length of extension or compression and is measured in meters. F is called the restoring force because the spring always attempts to return to its equilibrium position. K, or the spring constant, is the number that represents how much force it takes to stretch a material. Materials with a larger K constant are stiffer. This also means that the stronger the K constant, the more force can be applied since the object will be more rigid.
Amanda, and today I will be using a slinky to mimic the effects of force on a metal under tension. In doing so, we will see the object's elasticity or ability of a body to return to their original shape after a deforming force has been removed. Before I do so, I want to first start off by drawing a graph that demonstrates the correlation of applied force and elongation. As you will first start to notice, the graph begins by increasing steadily in a linear manner up until the proportional limit. This is because it reaches a point where the linear elastic behaviors end. Then it increases up until the elastic limit where the object slowly starts to deform. This is because it enters the plastic region, where the object is stretched too much to the point where it no longer returns to its original length. If we reach the peak, we know that the exact length the object can be pulled before it breaks. This is because the max force is applied, and past this point the object breaks, hence the breaking point. The spring in action, I will first start off by showing the spring by stretching it in its elastic region. This is where the object is allowed to move back to its original position no matter the force applied. Then I will show you the plastic region. In this plastic region, the object is stretched so much so that the force applied is enough to make the object deformed. And if force is greater than the object's ultimate strength and acted on the object, then the object will eventually break and reach its breaking point.
The action of stress and strain is also presented in our video. Hooke's law states that the change in length is proportional to the applied force. The change in length of a stretched object depends on the applied force, the length, and the cross-sectional area and the material, as shown in our video. The equations to use in these situations are stress equals force over area, while the equation for strain equals change in length over original length. There are two kinds of stress, which are compressional and tensional. Tensional stress is when objects are stretched, whereas compressional stress is when objects are under compression.